All right, calculus, welcome. Here we are on Thursday, January 6th. I'm going to give you some answers to this exam review video. We are going to start off semester 2 with that chapter 3 exam on Wednesday the 12th and Thursday the 13th next week. All right, so here's what we're going to do Thursday. Numbers 13 through 16 here say find an equation of the tangent lines to the curve at the given points. All right, so we don't have to do the limit as x approaches a of f of x minus f of a all over x minus a. All right, to find the slope at that given point. Instead, we can find the general derivative and we can plug our value of x in, and we can find the slope at that point 1, 2 as well. All right, so here is the function 5x minus 3x squared. So the derivative would be 5 minus 6x. That is the general derivative. So if I want to find the instantaneous rate of change at any x value, just plug whatever x value I want. I want 1 here, so I'm going to plug 1 in for x. So 5 minus 6 is a negative 1. At the point 1, 2, this parabola has a slope of the tangent lines to the curve of negative 1. So y minus the y value, y minus 2 is equal to negative 1 times x minus 1. That is the equation of my tangent line. Very easy. Now, I made a mistake on 14. When you plug, first off, get rid of that x squared. Why would I have 8x squared minus 2x squared? That'd be 6x squared. So no, it needs to be 8x squared minus 2x. Then if you plug 2 in, you will get 228. 228. So the derivative here would be 16x minus 2. All right, 16x minus 2. That is the general derivative. So if I plug 2 in for x, I get 32 minus 2. My slope is 30. All right, so y minus the y value is equal to the slope times x minus the x value. So that those two should be pretty easy, 13 and 14. All right, we want to get those. Now 15. This is 3 times x to the 1/2. 3 times x to the 1/2. It is not this, because that's 3x all to the 1/2 power. It would mean that 3 is also inside the square root and only x is. All right, just a little FYI. So, made a little boo-boo here. I'm going to bring down the power. That's 3/2, so 1 power less. Okay, so that's the general derivative, which is 3 over 2 times the square root of x. All right, 3 over 2 root x. I'm going to leave it in that form because I'm going to plug 9 in for x. 3 over 2 times square root of 9. The square root of 9 is 3. All right, 2 times 3 is 6. 3 over 6 is 1/2. The slope of the tangent line to the curve, that curve at the point 99 is 1/2. So y minus 9 is equal to 1/2 times x minus 9. Okay, so that one is not too bad here. And then we got to do 16. That is definitely the quotient rule. Low, d high, derivative of the numerator would be a negative 3 minus high, d low. Derivative of the denominator is just 1 all over the square of what's below. All right, so what do we have here? Distribute a negative 3x minus 18 minus 2 plus. This is a negative 3x. To subtract a negative 3x is to add 3x. Well, the negative 3x and the positive 3x cancel. You have a negative 20 over x plus 6, all of it squared. All right, so that's the general derivative here. Then I'm going to plug negative 1 in for x. Negative 1 plus 6 is 5. 5 squared is 25. Negative 20 over 25 is a negative 4/5. That is what my slope is. Y minus the y value is equal to the slope times x minus a negative 1, which is x plus 1. Find the equation of the tangent line to the curve at the given point. Those are 4 for us to look at there. Those are pretty good. We might add a few more. Okay, we can always practice more. That'd be great. But those we should handle pretty well. Chapter 3, using our skills and taking derivatives from chapter 3, we should handle those. All right, 17 and 18 would also be easy questions. Suppose that the height of an object t seconds after being launched from an initial height of 50 feet is given by that. My displacement equation, h of t is equal to negative 16t squared plus 85t plus 50. It has an initial velocity of 85 feet per second. So velocity is the derivative of displacements. All right, velocity is the derivative of displacement. We talked in class why that was the case. We spent some time relating this back to physics. So v of t is equal to negative 32t plus 85. That is my equation I'm going to use here, my general derivative, velocity. So find the instantaneous velocity at time equals 2.5. I plug 2.5 in for t. My instantaneous velocity is 5 feet per second. It is almost at the very top, its highest points. Find the instantaneous velocity at time t equals 4. Plug 4 in for t right there, and it is heading down. The equation of motion of a particle is, where s is in meters and t is in seconds, find the velocity and acceleration as functions of t. All right, so that is displacement. The first derivative of displacement is velocity. Just use the general power rule there. The derivative of acceleration, or velocity is acceleration, or the second derivative of displacement is acceleration. Use the general power rule here to get acceleration. Though it's velocity and acceleration as functions of t. Another, hopefully, very easy one. Find the acceleration after 2.5 seconds. I take my acceleration function, 12t squared plus 30t minus 12. I plug 2.5 in for t. All right, I get 138 meters per second squared. Hopefully, a relatively easy page. And another one I wanted to look at here in class, the last one I wanted to look at, because the other ones are either what we talked about or very, very interesting. All right, so let's take a look at 27. I mean, it is true, if you wanted to break this up, 1 over cosine, you could, this is actually pretty interesting. You could split this up as 1 over cosine minus sine over cosine. What's 1 over cosine? 1 over cosine is secant minus tangents. Secant minus tangents. That is what that function can be simplified to. The derivative of secant is secant tan. Minus derivative of tangent is secant squared. This is interesting. How are those two related? So secant x, tangent minus secant x. So you could also write your answer like that. All right, now I did the quotient rule. Low, derivative of the top, derivative of negative sine would be negative cosine, minus high, d low, derivative of cosine is a negative sine. This times this is a negative cosine squared x. A negative 1 times a negative sine x is a positive sine x. A negative sine squared, or I'm sorry, negative sine x times a negative sine x. Then times negative 1 is still a negative sine squared x. Cosine squared x plus sine squared x is 1. So if I factor out the negative 1, I'd have cosine squared x plus sine squared x multiplied by negative 1. So ultimately, this is a negative 1. Sine x minus 1 all over cosine squared x. Which, negative 1 over cosine squared x, that is a negative secant squared. And then sine over cosine times cosine. Sine over cosine is tangent. And then times 1 over cosine, that's how you get the secant. So that's how those two are the same. Two different ways you can get that answer there. All right, so 28, here's an example one you have to totally simplify. So this would be the chain rule. This is u to the third, which would be 3u squared derivative of u with respect to x. So 3, write that, squared, 1 power less, times the derivative of this. 3u, 1 power less is 2, times the derivative of u with respect to x, so 9x squared minus 8x. Do 3 times this binomial here on the outside, and you can leave that as squared. All right, let's take a look at these last 4 on the page here. So natural log u. If you got natural log u, the derivative of natural log u would be 1 over u du dx. 1 over u du dx. 1 over u times the derivative of this with respect to x. So 1 over this times the derivative of this. Now the derivative of this would be secant angle tangent angle times the derivative of my angle. Derivative of 3x is 3. The derivative of secant is secant angle tan angle. Derivative of that angle with respect to x. The reason you have to worry about that up here, because what's my angle? My angle is just x. Secant angle, the derivative of secant angle is secant angle tangent angle. What's the derivative of x? That angle, it's just 1. So I don't need to rewrite it. All right, so and then what's going to happen here? Those are going to cancel. I'm just going to leave you with 3 times tangent 3x. All right, let's take a look at 30. Put the 1/2 on the outside. Derivative of natural log u is 1 over u times the derivative of u. Derivative of cosine 2x would be a negative. Sine of my angle, what's the derivative of this angle? Derivative of 2x is 2. So negative 2 times 1/2 is a negative 1. Sine 2x over cosine 2x. You can also call that a negative tangent 2x. All right. 31. Product rule. First function, second function. Product rule is derivative of the first function times the second plus first function times the derivative of the second. Derivative of this would be 12x to the third. All right. Times my second function plus my first function, 3x to the fourth. Derivative of this function, derivative of sine u, would be cosine u times the derivative of u with respect to x. So cosine u times the derivative of this. Derivative of this is 8x. Multiply those two together to get 24x to the fifth, cosine 4x squared, and then just rewrite that. And we are almost done here. 32. First off, divide everything by x squared. That'll make it much nicer for us. Please do that, or else you're going to get an answer that can still be simplified, and that's going to cost us some points. So, I'm working with this. Low, derivative of the top would be 9x squared minus high. D low would be 2x all over the square of what's below, and I've run out of room. All right, so I think this is going to be 9x to the fourth minus 6x to the fourth. So it's going to be 3x to the fourth. Looks like minus 18x squared. So 3x to the fourth minus 18x squared all over this. All right, that's as results follows. Okay, well, we'll finish this in class on Friday, if we have not done so already with the end of this video. And that is it, folks. That is Yak Math Videos, and we are signing out.